Good morning everybody and welcome back. Today I figured we should have a quick chat about the bio batteries and do a recap on what's happening with there and what we may have learned or not learned so far. But before I get into that, I want to give a big thank you to Hope and Tivon from the QEG and Fix the World project, where I am currently standing on their roof. Those of you who are into all this kind of thing will recognise where I am. They've very kindly put me up for a couple of days while I get a flight back to the UK for tech and supplies. The guys are asleep at the moment because the life of a laptop entrepreneur is not an easy one, and we were all up till 5 AM last night going through what's happening in life and swapping war stories, while Hope is sitting there editing all her video log and Tivon is making all the orgonite. You've checked out their orgonite before, I'm sure. Here we go, here's a couple of examples. They've been making pyramids, they've been making these beautiful pendants, they're making charging plates, and they've got the latest one, which is a sleeping aid. These are a charging plate for people, and they gave me one of these last night because I'm actually in terrible insomniac. So I've had 4 hours kip and I'm up and ready to go and start the day. Yesterday I was way over there on the other side of those mountains. I've come all the way to town, spent the night with the guys, had a rest, got up, done my videos, and now I figure we'll go through a few things for the bio batteries before the day starts, and you can follow us around Marrakesh with those later. So let's sit down over here in the sun and have a quick recap on the bio battery. Right, let's go through this bio battery story. The first question most people might have at this point is, having done GEET for so long, why am I now looking at bio batteries? And the simple answer is that over here in Africa and in India and in these remote third world countries, GEET, although it's an amazing technology, is going to be a little bit difficult for the local people to actually implement. They don't have the tooling and the equipment necessary to make it. The availability of parts is a little bit low, and it's just not something that they're going to be able to do easily and replicate. It really needs to be a sold product they can go out and buy off the shelf. Over here, everybody uses the Honda GX160 engine as their generators and their water pumps, which is one of the reasons why I picked that engine in the first place. So whilst other people try to take that to market for me, we're going to look at something else. The other reason is purely out of curiosity. I think the bio battery tech is absolutely fantastic. Now, the way it works is that you have microbes living in the mud, which are naturally occurring. They live all over the world, and they produce energy. What's actually happening is plants are absorbing sunlight, and they're absorbing CO2. We all know this bit. And they're converting it into sugars, which we know. What you might not realize is that this sugars, or a lot of it, is actually being pushed into the ground to feed the microbes that live in the ground. The plants and the microbes and the mycelia are all living in a symbiotic relationship. So the plant's pushing sugar into the ground in the form of glucose. Deep within the soil, you've got anaerobic bacteria, which are then breaking this sugar down, and they're producing carbon dioxide and water. Now what they're doing is they're not eating the whole sugar molecule. They're taking off one carbon and a couple of hydrogens and producing a different version of sugar as a byproduct. I think it's a glucose lactate or something it is. And then they're bringing oxygen from higher up in the soil, and it's producing water. So plants are actually making water for themselves and for the soil and for the microbial conditions in the ground that's supporting life. The bio battery is kind of tagging in on this process. It doesn't steal any energy from the microbes, it doesn't steal any energy from the plants. What it's doing is it's separating out the process of converting the sugars into carbon dioxide and water. So, having done a whole lot of study around online, and thank you to everybody who's been posting videos on bio batteries and mud batteries, great resource to have access to. Normally, your hydrogens are coming off of your sugar molecule, and they're combining with that oxygen to produce water. If you interrupt this process, you release the hydrogens as a hydrogen ion, so that has now a positive charge. And you can interact with it with a pair of electrodes and capture the energy. So an electron is taken off on one of the electrodes, goes through your device and is then returned back to the system on the other electrode, which completes the biochemical process of producing the water. If you want to get more in depth as to exactly how that works, there's plenty of videos around online that go through all this kind of stuff. There seems to be two schools of thought as to how to make a mud battery and bio battery kicking around on the internet. One of them is using dissimilar metals. So you've got like an earth battery, which is now a standard voltaic cell. So you've got a copper electrode and a zinc or aluminium or magnesium sacrificial electrode that you've stuck into the ground. And it is a standard voltaic cell, and it's being boosted in effectiveness by the microbial action and the availability of free electrons and free hydrogen ions in the soil that's being driven by the plant and driven by the microbes that are there. So that is absolutely fantastic. The other school of thought is to use non-sacrificial electrodes, and they're carbon-based. Now, you need to use an electrically conductive carbon. So my first battery, I've used standard charcoal, as that's what's available in this environment at the moment. Standard carbon isn't electrically conductive. You need to make the charcoal into an activated charcoal, which basically just means heating it to between 700 and 800 degrees Celsius in the kiln while you're making it. That gives you a conductive medium to play with. So the people who are working on the carbon-based stuff, this is what we're going to really look at. They're using graphite sheet as their two electrodes. And all the people who are having the most success with this, they've got a thin layer of mud, normally about 10 mil thick, with their first electrode, and then 30-40 mil of soil, and then another sort of 10 mil on the top. Often there's a little bit of water involved, sometimes there isn't. Some people have got a sealed container, so there's no air getting to it. Some people have split the two electrodes and they've gone for one in the soil and one in water, and they're pushing air through their water, and they've got an aerobic process going on. The most impressive ones I've seen so far are literally just putting two plates together in one tank, in one system. This is the most applicable in a real world use. We don't want to have lots and lots of little different jars and lots of things, and you certainly don't want to be running air pumps to push air through the water, because the amount of available energy from your bio battery will be consumed by your air pump. So to get around that, one puts plants in there, and I would like to use a pond environment and have my pondweed on the surface in a little skim of water that is producing the sugars to run the battery, and it's oxygenating the water. So now, in the separation in this battery, whatever's in the bottom is your anaerobic bacteria and microbes. So they have to be far enough down in the battery to not be poisoned by the oxygen. Your other electrode is sitting in the top of the mud, where it can access oxygen, and is allowing your aerobic bacteria to live and oxygen to be present at that electrode to complete the circuit. The mistakes I've made with my first one is I've used, as I say before, non-conductive carbon in the lower plate. So we need to use activated carbon there. I've then also got quite a depth of mud between my two electrodes. Now, we've just seen on the previous video that gas has built up in the bottom. That will be a combination of methane, carbon dioxide and hydrogen, or it would be hydrogen if we were actually pulling power off of it. And it's got trapped in that mud layer and is built up in the bottom. My upper electrode isn't in contact with the mud, it isn't in that system properly. So there's no exchange between the hydrogen and the electrons in the surface layer to generate the current. The other mistake I've made is I've taken a sheet of mesh and I've made a little tang on the end of it and brought it up through the mud and then slipped a piece of plastic around it to try to insulate it. But the water's in there, so it's electrically connected to the upper layer, and I've basically shorted out my battery in this process. And I think the other factor is going to be the type of mud and the density and consistency of it. The gas hasn't been able to propagate up through that layer and reach an upper electrode, which I'm also missing. So Depending on where you are and the composition of your soil, the distance between those two plates is going to vary so that you can get the transfer through it. A lot of the more advanced people and the universities and labs who are working on this have put a membrane in there to separate the two electrodes so that you don't have this internal shorting of the battery. Now, I don't know what everyone's using for those membranes. They're all keeping that kind of quiet. So if there's anyone out there who does know what you put between your two plates, it'd be great if you could let me know. Other people aren't worrying about having an insulating material in there, and they are quite successfully producing power with just the mud. So I want to go in that direction with this, because I don't want to make one little pot and have an LED blink. I want to be able to make 100 square meter sheet or sets of sheets in the bottom of a pond that I'm going to use for my aquaponic system. So if I can skip out having to put in an insulating material, that's going to reduce the cost of the installations. And it's going to make it much more easy for people in this environment to replicate this technology and to use this to produce power to run lights in their house and charge their phones and run their, I don't think they'll run a fridge off of it, but they've got basic low-level 12-volt power, which will be a big step forward in producing energy in this kind of environment. The other factor is going to be the conductivity of the soil itself. So the mineral content of the soil. When you make a normal battery, there is always an internal resistance in a battery. The lower your internal resistance within the battery, the better, as far as I understand it. So I'm considering doping my ground with ormus, which we'll come back onto on another video, to try and change the conductivity profiles and change the amount of energy available. And I'm also going to have to start working on how far apart my plates are. But before we get to that part of the process and that part of the development, we need to get to something where I've got two electrodes that can be mass-produced and reproduced in this environment cheaply and simply, that do the job they're supposed to do. So in my mind, that's activated charcoal. And there was one set of videos. If I can find the links again, I will put them onto the comments page down below so you can go back and have a look at them, where some very clever people have done more or less the same thing I'm doing. They've used the same stainless steel mesh. They've then painted it with an epoxy resin of some form and dusted it with activated charcoal. And they have one plate at the bottom with a bit of mud around it and another plate, a little skim. And they've made small pots, about 100 mil round, and stacked up thousands and thousands and thousands of them inside a shipping container. And they have got some serious power output to the point where they can arc out their two wires outside their container. That is very impressive and it's very, very inspiring. So I want to take that concept, which is exactly what I was thinking in the first place, and run with that and see how far we can push that. Now, to my mind, the best thing to do next is to switch from just activated charcoal to graphene. Now, graphene, you may or may not have seen, is a single atomic thick layer of graphite that's held in suspension, and you can dip plates in it, and you can dip material in it, and you can coat metals with your graphene, and it has phenomenal properties. So I'd like to give a really big thank you to Dr. Murray Smith, I believe it's Dr. Murray Smith, for all of his work on graphene and for posting so many videos on how to produce it and all the different ways that you can produce it. The one I've picked is using the ultrasound cleaning bath tanks. This to me seems like one of the best ways to go. I believe on one of his videos he was saying to use a 300 watt tank. Couldn't get a 300 watt tank, I've got a 75 watt tank, so I'm hoping that it's going to be powerful enough to do the job. So I've ordered some activated charcoal, which is used in a fish tank filter, and a 50 micron mesh as per his recommendations, so I can grind my charcoal, put it through my mesh and produce a very fine powder of electrically conductive carbon, which I can then put into either acetate or black tea. It says that tannin, tannic acid or tannin, will do the job just as well. So we're going to have a little play with this. My tank, my mesh and all the rest of my equipment has now arrived in the UK at my dad's house. I have to go and renew visas anyway, so I'm going to take a flight from here back to the UK, pick up all my tech, and then come back here next week and start making graphene solutions and coating stainless steel mesh sheets with this very, very conductive, very high surface area material. And we'll go again with the battery, and we'll start with the same box. We'll get some more mud, and this time I will put a small thin layer of mud on the bottom, maybe sprinkle in and dust in some activated charcoal, lay in my sheet, bring in the mud layer, and do the same again, so I have two properly fitted conductive layers in there. And this time I'm going to attach a wire to them with an insulator, so I'm not routing power from my lower plate up, round through and shorting out all of the battery. And then we'll have another go and see what we can get coming out in terms of power supply. Now, we've seen on the previous video anything from half a volt to a volt. Voltage is great, current is what you need. My test equipment is not really sensitive enough to read very, very low currents. So we'll go with a resistive load and allow that to track the electrons round. Because if you're not moving the electrons round, then the microbes are going to go into a standard respiratory process and produce carbon dioxide and water. I think we need to put a load on this thing to actually encourage the electron flow and the hydrogen and proton flow to establish itself within the mud. Also, having a resistive load allows us to check a voltage potential across a resistance and calculate what current we have. Once we know what current we have, it's going to be time to work out how do we extract that from this mud battery. And the most obvious and easy solution is to use Joule Thief. Now, happily, Tivon is also working on some very advanced Joule Thieves. So once I can say to him, I've got this many volts and this many amps, he will be able to set me up a really, really nice Joule Thief system. And we'll start to see how much power we can pull off and buffer that into a nice lump that we can then send in a pulse to whatever we want to drive. The other reason for using graphene is the graphene supercapacitor. Batteries, not so good. We don't want to be going out and buying huge stacks of lead acid batteries at great cost, which have a very limited life expectancy, and trying to charge batteries that we can then run our equipment from. I want to use my graphene that I'm already producing from my electrodes to produce my power storage, and then all you have to find is pieces of aluminium sheet, paper separators, the right electrolyte for in there. So again, back to Dr. Murray Smith's work, because he's already done all of this development and posted everything. Even though he's running this as a business and he's got product going out there, he's sharing all of his research and all of his knowledge online for everyone to use. So I'm going to go through, work with his recommendations and see if I can produce a bank of small capacitors that we can charge up and a mud battery that's a prototype for the process that I'm going to use here in Azoud, and then combine that in with all the aquaponics things that will be coming up later on. Okay, that little lot is going to take me a couple of weeks to sort out. So in the meantime, I'm going to work with Hope and Tivon for the next day or two, and they're going to put me through the QEG Academy. It's the training ground for entrepreneurs to how to take your technology and your product and actually monetize it in some way. Because doing all this stuff is incredibly expensive, and my income is actually less than your average Berber living on the top of that mountain over there. So time to get my business head on, get my websites in order, get my products in order, get my geek plans out to you all, because there is a full set of plans with video, with how-to tutorials and paperwork that tell you how to build a Honda GX160 geek system that you've built everything right, and then you can go through retuning and playing and learning under your own power how to make a geek system. I've got a few other products on standby, so this all needs to come together in a package. So enjoy the rest of the show, and I will see you very soon.